Good day time and welcome. We're going to talk about a little bit about OpenStack Observability. Just out of curiosity and to get you woke up here, who is using OpenStack Telemetry? 3, 4, and I lost count after 20 people getting in, so that's an interesting data point. Let's take a peek. So first, we are going to do some quick introductions, and you can basically read the slides. We are going through what we have today in OpenStack Telemetry, take a step back and see what's out there in the world outside of OpenStack, what is being used, and how we could put things together and use it a little bit differently. And Jamie will present some outlook how it could look like in the future. So first of all, would you introduce yourself?
My name is Jamie Parker. I am a product manager at Red Hat. I manage the Service Telemetry Framework product and also the Horizon UI product for OpenStack.
Yeah, and I'm Matthias Runge. I'm an engineering manager at Red Hat. My team is working at the OpenStack Observability. By coincidence, I'm also the telemetry PTL and maintaining, for example, collectd among other sites. Thanks. So you may have seen this kind of architecture before. So this is in the OpenStack documentation, so no need to take pictures here. So on the top, you have probably seen this wild diagram of OpenStack components hooked together with lots of APIs and communication between. That's all hidden on the top. On the left-hand side, we have ceilometer, which is just talking to the OpenStack APIs and also snooping in the notification bus. Then it uses the information and is also pulling out of APIs. The interesting thing here is that the information is then pushed over to something called notification agents, and that is either being sent to panko or Gnocchi. As a side note, panko is gone since Yoga, just because it didn't scale. And Gnocchi is the time series database to store any metrics. And on the other side of the screen here, there is A or aodh, depending where you are or where you live. That is the alarming component, which can be used, for example, to enable autoscaling. And the way how A is working is it has a list of alarms stored in a database, and it constantly or repeatedly pulls out metrics out of Gnocchi and compares this with a preset value and issues either an alarm or not. Pretty easy. So today, OpenStack Telemetry is mostly ceilometer, which is I would say, agent or component that collects all metrics. Then it's Gnocchi as a data storage and aodh or A. What we did not see here in the picture is anything else like below infrastructure metrics. What's going on the hardware? You could use things like collectd or node exporter or statsd or something else. And you would probably use this to get RAM, CPU, disk usage, disk I/O, also temperature, ventilation, voltage, all that kind of stuff. That's these things you need to know how your infrastructure is doing. And then we have additional services that are required to keep an OpenStack up and running, like MySQL or MariaDB. You would probably want to know how Rabbit is doing. Otherwise, shut your Rabbit off and see how OpenStack is behaving. Ceph or like in Apache, anything that handles API, you would probably want to notice how things are going here. And there are two aspects. Both is the API available and also how performant this is. And then we have other tools existing in the observability space. I've briefly touched on Gnocchi, which is the time series database. There are other options, potentially more popular, like Prometheus, InfluxDB, Elasticsearch as a data store for storing logs, and also Grafana to visualize all the things. I did not touch on any centralized logging so far. So you would probably want to collect all the logs and unify them in a single storage instead of SSHing to like 100 machines and checking logs. I briefly touched on availability. Is my API healthy? Is my service running? And so on. There are traditional tools in the space like Sensu or Zabbix, or we've seen earlier today. I forgot the name. Stackmon, right? I briefly mentioned performance monitoring. So if you're moving towards something else, you would probably want to use something like exporters. And I'm getting to this in a moment. So taking another step back, there are a couple of open standards out there that we may want to think about and may want to include. And that is, for example, OpenTelemetry or OpenMetrics. They serve different purposes. OpenTelemetry, for example, could be used to debug things like what is going on, what's failing. If you think about, you have a customer that is complaining about the service is being slow. And then the question is, what do? You typically go there and SSH and see what's going on. If you would be using a thing like OpenTelemetry, you would be able to trace and see, oh, there's an API request going to Nova, or there's an API request going to Cinder, and then it's spawning a connection to Keystone, and then it's doing the connection to the database, and you would be able to see where things are being slowed down. So this enables a much more deeper debugging. It could also expose metrics like runtime metrics, or how much time do we spend in a function named foo, for example. That enables for mostly debugging. If we go to OpenMetrics, that would allow us, or could allow us to trace more, like how much memory is using the user with the UUID, blah, 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 blah. How many volumes do they have? So if you look at the right-hand side, and I don't know if it's really readable or not, but actually it doesn't really matter. It tells the name of the metric, and then it gives you additional labels. This metric belongs to user blah, blah, blah. This metric is running, or this is created in a project, belongs to a VM, blah. This is pretty easy readable, and for the standard is called OpenMetrics, and by coincidence, it's the same standard that also Prometheus uses. So it's just an endpoint which would be accessed from Prometheus, and it would just ingest the metrics. We've done a proof of concept or something. So I've mentioned before ceilometer notification agent, or ceilometer notification. So in this case, we have which is on the left-hand side in the middle of the gray box. There is a component named sgcore, which is basically an exporter that is directly hooked to the ceilometer notification agent, and that can expose ceilometer metrics directly in a way that it can be scraped by Prometheus. And the rest is very comparable to what we had before on the second slide or third slide. So if we do this, we get a list of metrics, and this is just a very brief capture. And actually, what's written there, it really doesn't matter. So we could do this by adding the n exporter to ceilometer notification, to the ceilometer notification agent. Or we could use the OpenStack exporter, which is an external project. Or we could do this much more finer granular and add exporters to every OpenStack component. The code changes would be very little. This could be done, for example, by using the Prometheus client instrumentation library. Or an own exporter can be written. As shown before, the code or the format is pretty readable, pretty easy to write. The benefit I see here, for example, is that one would not rely on ceilometer or as a component or project user. If I would be writing code for Nova, I could just use curl and get the metrics out of Nova instead of relying on something else that needs integration and would be released in a next release. And that is where Jamie comes in.
So metrics are invaluable. That's how you determine the health of your system. That's how you see where things are going wrong. You can add even more value to metrics with visualization because it's so much easier to tell at a glance this is going wrong. So how we do this, we're using Service Telemetry Framework. So what we do is Service Telemetry Framework is built using a series of open source-based components. And I want to talk a little bit about how it's built, what we're using, and then also some upcoming enhancements where all of those telemetry pieces and visualizations will be improved. So right now, we are moving our metrics collection. We have been using the Elastic pieces for metrics collection. We are moving to the Red Hat Observability operator. What this will do is instead of using community pieces, this will give us a fully supported Red Hat Prometheus stack. Still, Prometheus is the underlying component, but fully supported with internal Red Hat teams. It gives us the option to enhance collection in the future, so we'll be able to enhance these metrics collection stacks. We are changing our certificate management system. We're going to be using Certificate Manager, Cert Manager for OpenShift. What this does is this allows us to upgrade STF in the future. STF runs on OpenShift now. It collects metrics from OpenStack, but actually runs on OpenShift. With the Cert Manager deployments, we'll be able to upgrade to continuously to different versions of OpenShift and take advantage of enhanced Kubernetes features there. Also, very important for many people, end users, many people need to run OpenStack in disconnected mode. Both of these changes, with the changes to Cert Manager and the changes to a supported Prometheus stack, will let us run STF in disconnected mode. So that's going to be a big enhancement for many people who are currently using it. We're moving away from community-based Grafana. We are moving into a native OpenShift visualization. So this is just a mock-up to give you an example of what this is going to look like in the future. So you'll be able to use dashboards at a glance to really see what is happening with your metrics collection. And it's going to be much more natively and cleanly integrated into the OpenShift UI. Even further in the future, we've been talking a little bit about OpenStack 18 within this conference. We have some even further enhancements for visualization. So we're actually changing the OpenShift Observability UI to using Perseus, which is an open source project that will be a little bit more Grafana-like. People will be able to create their own dashboards, change the dashboards, really give a much better customization technique to that, and a lot more flexibility there. Also, with the movement to 18, since we're going to be running on top of OpenShift, our Kubernetes platform, it gives us more options for logs. So you can pretty quickly use logging within OpenShift to gather your control plane logs. And you can use OpenShift logging for that. OpenShift logging is based on Vector for log collection, so that's an open source product, and also Grafana Loki for log storage. With Vector, you can also forward logs off cluster. So all of your control plane logging, you could gather that, collect it, forward it to whatever log containment system that you're using, Splunk, or you could use Grafana Loki. And that gives you one place to view all of your logs. So much more flexible and powerful way of using logging within OpenStack. And that's our presentation. So if you have any questions, we have our emails listed here. We're happy to take any questions that you have now. Yes?
Have you given any thought to how you can collect? So you're currently running in OpenShift. You're collecting metrics from OpenStack. If you've got a different OpenShift cluster, for example, a shift on stack cluster, have you given any thought to how you can collect metrics from that cluster into the same Prometheus database as that is collecting your OpenStack?
So the way of Prometheus is collecting metrics is basically it takes a label in OpenShift or in Kubernetes, which basically marks a container as observable or as exposing metrics. And if you would do this the same with your OpenShift cluster, with like the shift on stack cluster, you could do it that way, or you can also provide that Prometheus a list of IP addresses / ports to scrape from.
I mean, if it's in a different cluster, then. So
As long as you can reach that, that is one way. The other way would be to use something called remote write.
So would that push?
Remote write pushes,
Okay.
otherwise it will pull.
Cool. Do you know if we're going to productize that?
At this point, I can't answer that question, but I'm happy to follow up.
Yeah, hi. I have actually a couple of questions, maybe two, something like that. So you mentioned on one of your slides OpenTelemetry, but isn't it something that's already implemented by OS Profiler in all kind of projects as of today? Because it's basically also traces like logs, how long it took to make some, I mean, you know, that.
Yeah, so there is OS Profiler. I'm currently a little bit unsure on the state of the project, since it looks like it was proposed in 2018, like a couple of years ago here, and then it didn't get any traction.
I would say that it's kind of being used by users as of today. I'm not sure about like how it's adoption overall projects, but okay. And second, so what was your experience on using Grafana Loki for well at scale under some load regarding alerting on logs? Because basically it's post-processed and it's stored in S3 storage, so it should like then fetch it, and I mean it's I/O, and you need to kind of act sometimes fast on log alerts.
So we do have log alerts implemented in OpenShift logging using Grafana Loki. We find it to be fairly performant. We advise it as like a second layer of security. not necessarily as your number one layer, because logs can be delayed, logs can be lost, logs are not 100% reliable. You know, the server goes down, then the logs disappear. And you can do some amount of buffering around that, but it's not 100%. So we use log-based alerting as a secondary, or maybe even a enhanced version of monitoring. We don't advise it as the only version of monitoring. But yes, we find that it works fairly well at scale.
Okay. And second, I mean, have you heard something about Venus project that's basically designed for logging? I'm not sure what state it is, but maybe you know more. So it's.
Yeah, I've seen this being mentioned on the OpenStack mailing list. I don't know when. It feels like it's at least 2 years old or even older, and I haven't seen any traction afterwards.
Okay, thanks.
But I may be totally wrong.
So you mentioned the vector log collection. So is it an agent-based or is it an agent-less? Like how are you going to fetch the metrics from all the components of OpenStack?
Well, Vector is for logs. So right now, Vector does the in-cluster logging. So whenever logs are written to disk, Vector scrapes it and then collects it and does whatever you tell it to do. It can go to multiple endpoints.
So just an endpoint is to scrap that, or like?
Yes. So Vector, the way we currently have Kubernetes set up is that the logs, especially like event logs, are written to disk.
Okay.
And Vector detects that they've been written to disk and then takes them, scrapes them, and sends them wherever you tell it to go.
So is there any software that Vector install? How Vector knows?
It's operator-based.
Okay.
So it's an operator-based software.
Cool. Thank you.
Yeah. So first of all, I can talk about OS Profiler. We have an effort currently to develop an OpenTelemetry driver for OS Profiler. That might be of interest to you. I think patches are on for review or something. I don't know. We are going to see how it behaves at scale. You know, there is still the question that OS Profiler is only when you specify the header, not all the time. So we might need to change something here. We'll see. We explore it, right? Okay. And for the question, yeah. So you are talking about adding a native /metrics as in an OpenMetrics endpoint
Yes.
to services, so like
Yes.
all that in your tree.
Yes.
Do you envision that endpoint to be authenticated?
Of course.
All right. Okay. So with Keystone? No, please don't. Like how would you describe that possibility?
So you need to make sure that only authenticated or specifically authenticated users are able to get the metrics out of this, since you could consider the data as private.
Yeah.
And I wouldn't necessarily use Keystone to authenticate this, especially since there are also other services, like I've mentioned, MySQL, Rabbit, and Oven or whatever. They would be observed the same way. They expose the endpoints anyways, or Ceph.
So you would use some other mechanism with some reverse proxies instead?
There are multiple ways to do this. You should probably also encrypt the data.
Okay.
Yeah, thanks for maintaining CollectD and telemetry. So we have some moderately large Swift clusters with like I think thousands of disks and hundreds of servers. We tried to put the logs of this type of cluster into Elasticsearch, and then we log terabytes and terabytes of logs per day, and it's become not usable. And then my question is then, how do you filter logs so that it becomes useful?
That's a good question. We run into this problem, particularly with Kubernetes events as well, because those are the same depending on what a user does. A user lists all namespaces. All of that is written into the event log, and then all of that gets sent out. We are currently working on filtering for that. I would suspect that we would need to do something similar for OpenStack, where a user could define the level of logging that they wish to receive from Kubernetes events. So we would need to do something similar, I suspect.
Other questions?
I think there was also a metrics project as well, but that used some kind of, I think, Unix socket to pass metrics through it and then export it. How is your relation with that one?
Basically, there is no relationship.
Because I guess only one of them should survive, like you don't need multiple parts the same metrics.
Yeah, so
Make them at all would be quite nice.
we have seen in the past a lot of projects popping into the OpenStack area, I would say. The health of all these projects is more or less unknown. And I would love to keep something much more maintained.
So we're a user of ceilometer and panko, and the question is then, as panko is dead, what did you do now? What is the recommended way to replace it? Because I think we're running Victoria, which is I think the latest release, but the rest is all yoga. What is the replacement for panko?
There is no replacement. So basically, I did not hear any complaints about panko being dropped. I've seen a lot of complaints about panko being very slow and also filling up the disk, and nobody really can use it. I've seen like a use case where users were basically using panko for auditing reasons.
We have maybe a similar weird use case. We store all the events we get for billing reasons.
Yeah,
And then as a billing job that crawls just all that happens.
It takes 18 minutes per project.
Oh. I've seen a different use case where the customer was using or exclusively using Horizon for interaction. So they were basically parsing Horizon log files to get the exact same data.
Because it said if your organization is interested in panko and you want to continue to step in and maintain it, you always can reach the technical committee and project can be revived.
Yeah, but
Just
basically,
because it says that it's, I mean, it's dead because there is no active maintenance for it, but if you like need it and it's relevant to your organization, you can.
like for us, there's also not maintaining part because it's used as is. There's no additional requirement on it.
Yeah, but I mean,
There's nothing to-
it's still like Python versions going on, and you would need to upgrade your lesson sometimes. So
Let's use all the
It's okay,
So-
it's just easy to live. You don't need to maintain and make new features.
yes, exactly. So it's basically keeping gates green.
I mean, in the worst case, since there were no changes, and if you would revive this, you would revive it, and then you would have like the status of what's in Yoga, and you would use that Yoga version within your Antelope cloud. So that's also a possibility. If you want to step up, you're more than welcome. Okay, thank you very much.
Right.